use Redwood to kind of build your application and use Yang's product Plasmic to then visually design all of the components, all those cells, kind of on top of that. I think it'd be a really powerful stack. But anyway, I'll introduce Yang and he can tell you about Plasmic. Yang has had an early career in distributed database systems and machine learning, which is both stuff I don't know that, but sounds really cool. But over the years of working those things, he developed a love for front end. He went from big company to big company like Google and Microsoft. Wow, that's incredible. To early stage startups, which I think most people move that direction because it's more fun. Yang has spent some time with React and JS, and that time has seen him build some complex spreadsheet apps, which I think we all build complex spreadsheet apps really when it comes down to it. Massively multiplayer real-time browser games, which is super cool, and I would love to see that Yang at some point. And Yang is now building and obsessed with his app called Plasmic. So I'm excited to hear about this, and I think as you hear about it, you'll see how it can kind of fit into the Redwood ecosystem, and I think those two things could work really cool together. So Yang, take it away. Go ahead.
Awesome. Thanks so much for the intro. I'm going to share my screen here, and let me know if that is showing up.
I can see it. Thank you.
Okay, great. Awesome. So I'm excited to be here. Thanks for having me. I'm basically going to be talking a little bit about this project called Plasmic, which is something that is a project that started a while ago as just this passion project. It's a visual builder for React, and it's a tool that I hope can be useful to all React developers, but also just interesting to learn about and talk about as a React project itself. And it's something that so far I find has a really nice fit with these Jamstack frameworks like Gatsby and Next, where the site you're creating actually has the potential for heavy design elements and is like, mostly static, content driven, that kind of application. So I'm going to start by taking a step back and talk about the motivation for this. So like I said, Plasmic is a visual builder for React, and basically wanted to solve two different problems with it. So the first is just from our experience on product teams, where you have these designers and developers working together. Sometimes that collaboration can be complex. For the times where you as a developer are able to work with a designer, and you're lucky enough to have that resource on your team, it can be a lot of fun. Or at least I've always learned a lot from those experiences. But at the same time, when it comes time to actually do handoff or to actually translate these designs into code, that's where things can get a little dicey. And by that, I mean, designers are essentially using these tools like Sketch or Figma, these drawing programs, to create these very high fidelity vector drawings of what a UI should look like mocked up. And then it's your job as a developer to take that design, that drawing, and turn it into the real product. And you're doing this from scratch by hand using code. And inevitably, a lot of things get missed in this translation process. Or it can just be hard to do that translation because designs are freeform drawings, and so you have this this back and forth between design and development, and ultimately you have these two sources of truth on product teams that by most teams' admission, I think is never truly in sync. So that's kind of the first problem that I wanted to solve, is just streamlining this collaboration and translation process. Whoops. And the second reason for working on Plasmic is really about rethinking the developer experience, what that could look like. So this is just to let those of us working on front ends build a lot faster. UI builders are actually nothing new. They've been very widely used, especially on other platforms like iOS and Android and Windows. Shipped into all sorts of major apps. And I think just haven't seen that for the web quite as much. And to build one that is that fits well with the web means fitting well with how applications are written today. Largely using these compositional component frameworks like React and Vue and Angular, and or at least increasingly these days. And I think also just trying to come up with a UI builder that is a lot easier and simpler to use, something closer to a design tool than I guess UI builders of yesteryear. So that's a little bit about the setting stage for Plasmic. So with that, I'm going to switch gears into a demo. So this is the tool. It's a browser-based tool, and I'm going to get started by creating a new project here. And for this demo, I'm actually going to create everything from scratch. And what I'm creating is ToDoMVC. So I'll show you what ToDoMVC looks like just as a refresher. Everyone's favorite, reference app. I'm actually not going to create the whole thing, in super detail. I'm actually just going to create a subset of the app. But and the way I'm going to create it is from scratch. So there's actually another way to create things, which there's a video on our website where you can see how to create things from, like if you already have a Figma file or a Figma design, you can actually import that into Plasmic. And what this does is it does all the automated conversion of these like, Figma document representation concepts into web standards. But for here, I'm going to just get started by drawing things out. So I'm creating this new artboard, and the whole workflow in Plasmic that it tries to enable is just to let you create things starting with very rough exploratory designs. So I'm just going to create this wireframe right now with like the title here. I'm going to make the title huge and just put it roughly in the center of the screen. I'm not really worrying about layout or anything like that. And below it, I'm going to draw this card for the actual task itself and a checkbox, which I actually want to be circular. And right next to it, I'm going to add some text for the actual task, like buy some milk. And that is pretty much it. Oh, am I still sharing my screen? My screen just froze. Anyway, so this is my task. Now, I want a list of these tasks. So one thing I can do is just, copy and paste this a bunch of times. But then when it comes time for me to actually style these things and make them look different, then I have to, update each of them manually. So I don't really want to do that. I don't want to just copy and paste them. I actually want to, what I'll do is I'll right click this and create a component out of it called task. And with this, I can actually reuse this thing in a bunch of places. These are all instances of that same component. And I can double click into one of these instances to start editing the primary copy of it. So if I make changes, then those are reflected across all the instances. And that's, the kind of instantaneous feedback that this tool is trying to give you. Now, that's actually pretty much it for my wireframe. From here, I'm actually going to start applying styling to make it look more like the real thing. And actually, I'm going to keep the, I think I closed the window for the real thing. Again, that's kind of roughly what I'm going for. So I'm going to start with styling this title, and I'm going to make it super thin. And I'm also going to give it this sort of light red hue here. And I'm also going to set the background of the whole page to be this off-white, warm gray, maybe something like there. And so, this is the kind of like rapid feedback, again, that it tries to put you in the flow of. These tasks, I want them to be pure white. And I'm going to actually take these checkboxes, and I'm going to actually first remove the background from them and then set a very light border color here. And the text itself, I'm going to actually make larger, and I'm going to give it a lighter color here. I'm going to save this color actually as a reusable color token called, let's say, text color. And color tokens, spacing tokens, mix-ins, these are all concepts that exist in Plasmic that help you kind of create these much more maintainable designs over time that are lasting. So so this is, again, the kind of workflow. We started with something that's very rough, and then I'm gradually refining it into something that's real, that's robust, and the next thing I'll add is layout. And so that's the whole workflow is start rough, refine, 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 and then end up with something that you actually can ship into production that's, just as robust as any component that you write by hand. So the tasks here, I just kind of, haphazardly arrange them into this vertical list. But what I'm going to do is I'm going to lasso them into what's called a vertical stack. So this is one way we can start introducing layout into this design. And this vertical stack, what it does is it keeps everything distributed in line always. And this is powered by Flexbox. And you can see the controls for this here. And what Plasmic tries to do is really just streamline a lot of the layout controls in when you're creating your designs, because they're just such a common cross-cutting concern whenever you're creating anything visual is just layout. Simplifying CSS layout is actually a big focus of Plasmic. So just to show a little bit of that, I'm going to first remove the background here. I'm going to align everything to the top, to the left. I'm going to double click an edge to auto size the content vertically and also horizontally. These are some of the simpler features in the layout engine. I'm going to show some more interesting things later on as well. And I'm actually going to call this element, I'm going to give it a name called task list. This is just to help keep my elements organized, but also it'll come in handy later for the actual code gen part. So these tasks, they all currently say the same thing, which is kind of boring. I want them to say different things. In fact, I want it to be variable. So what I'm going to do is I'm going to start editing this component again. And I'm going to right click this text and I'm going to convert it to what's called a slot. And slots are basically like poking a hole in the component. So from outside of this component, from any one of these instances, I can select that slot. And for instance, I can just change the text by directly typing make ToDoApp, give a demo. But you can actually fill up these slots with arbitrary content, any number of elements as well. I think the last thing I'll do with this component is just design it out in its different states. So this is super common with React components, is just making them look different in different circumstances. So what I will do is first, instead of just continually double clicking back into this component, I'm going to right click this and pop it out into its own new artboard, like so. So if you're familiar with like React Storybook, it's the same general concept of just being able to edit one thing in isolation and focus on it. So now the way that Plasmic represents and models these concepts like states and variations of a component is through this one unifying concept called variance. And I'll just show how it works. I'm going to create a group of variants called states. And inside of states, I'm going to create a state for my completed state, what it looks like when it's being edited, or what it looks like when it's marked high priority. So these are all going to be, I want to make them all look different. So actually, for this demo, I'm just going to design out this completed state. And for the completed state, I want there to be a check mark in this checkbox. So I'm actually going to screen grab this check mark from the reference app because I like the look of this check mark. And I'm going to paste it in here as well. I'm going to zoom in here and I'm going to adjust it a little bit. This is actually, you can also use automated layout, but it doesn't really matter for this case. And so I can now switch between my base appearance and my completed appearance to see the difference. Now what's going on is this is actually not a copy of the base component. It's actually just a set of deltas or overrides on top of the base appearance. So to show you what I mean, I'm going to clone this artboard and have it sit kind of side by side. And I'm going to set this one on the bottom to look at the base appearance and the one on top to look at the completed appearance. And if I make changes to the base appearance, they do bleed through to the completed to the other variants. But if I make anything that's being recorded to the completed variant, those are specific to the completed variant. So as another example of this, I'm going to take this text and I'm going to make it strike out and change its text color to be this very light gray here. And so, I think that's pretty much it for what I want my completed appearance to look like. Now, the thing about variants is that you can actually dynamically combine any number of them. So for instance, let's say I wanted to introduce a hover variant here. And hover variant is just something that Plasmic has special support for because it's so common. And I'll see what that means in a little bit. But whenever I hover over any part of this task, let's say I want this circle to become darker. So I'm just going to set its color to be darker, like so. And now, since hover states are something that we have special support for, you can actually just switch into live preview mode and play with this to get that some quick feedback on what it feels like. And this is close to what I want, but I noticed actually another thing that I want is for there to be this pointer to be a hand pointer as well. So I'm going to just set that and try it again. Okay, so that's better. And the thing about these variants is that they come with the component wherever it goes. So back in my main screen, I can select any one of these instances and set it to be, just for the purposes of mocking this up, I'm going to set this middle one to be a completed state. And I can also play with this whole thing. And, it's a little nuanced here, but you can see that the middle guy is dynamically combining the hover state and the completed state. So that is pretty much it actually for what I wanted to do for designing this app. I think the last things I'll do here is I will tidy this up with real layout that is centered and maybe has some padding on the top and bottom. And then I'm going to turn this whole screen into a component called ToDoApp. And that's it. So from here, this next part is the interesting part, which is how do we actually work with this from the code? And to get started with that, one way you can actually start really easily is just click this button to spin up a code sandbox and immediately see it running as a standalone web app. But actually for this demo, I'm actually going to take these components that I created and pull them down into a, import them into a local code base I have just sitting in a Git on my file system. So there's this CLI that Plasmic comes with that I already have installed. So I'm going to skip this step. The two other steps are basically running this command, which is just something you run the first time you want to get started using Plasmic on a code base. So I have here this blank create React app, and just to show you what that looks like, I'm gonna pull up the running app here. It's just a spinning logo, and of course you don't have to start with a blank create React app. You can start with any React code base, Gatsby code base, etc. And I'm just going to run this command, and what it does is it asks a bunch of questions. I'm going to go with the defaults, and it spits out a Plasmic JSON. Now the next command after that is this Plasmic sync command, which is what actually pulls down the two components that we created. The two components being the ToDoApp and the task component. So I'm going to copy that command, and I'm going to paste that in here. So this should pull down the two components. And I'm also going to pull up my code editor in the meantime. So we sync those down, and at this point, this is basically what is currently in the blank create React app. It's just this boilerplate, this spinning logo. So I'll have the spinning logo running on the right. And I'm going to replace all this with just getting things on the screen. So I'm going to just put my ToDoApp onto the screen like so. And I think autocomplete is that working? Or maybe I have to type this in type in the import manually. Oh, okay, cool. I don't know why my computer seems to be chugging right now. But anyway, so with that, I have exactly what I created in Plasmic running, as a pixel perfect rendition in my own app. But of course, this is still the mock data, and what I really want is my own, dynamic data powering this thing. So I'm going to click into this thing. This is the ToDoApp component file. There's a lot of comments here, but I'm actually going to delete all of them. Whoops, like so. And so this is actually, this whole file is really very simple. The ToDoApp component is just a thin wrapper around the Plasmic ToDoApp. So Plasmic ToDoApp, what this is basically a dumb presentational component that is generated by Plasmic, and it's actually owned by Plasmic. So this is just a file that you don't have to work with or touch or anything like that. And you're just importing this into your own code base, and as if it were any component from a component library or something like that, and just rendering it. And so it handles all the presentational aspects for you. And the ToDoApp component, this file that we're looking at here, this is actually owned by you. Plasmic just generates this as kind of a convenience, giving you a skeleton starter, but you can do whatever you want with this file. So this is, as an example, this is a place where we can add our state or our logic, or behavior, event handlers. So I'm going to just get my own state onto the screen by, let's say my state was living in some local React state. So I'm going to define that here. And let's say my task objects are just simple JS objects with a name property. So like do stuff. I'm going to have 3 of them, like so. And this Plasmic ToDoApp, this component is actually very flexible. You can wire up props to any elements inside of it. So I'm going to say, I'm going to reference that task list container. Remember, we gave that a name earlier. So I'm just going to reference it by name. And I'm going to replace all of its contents with my own set of tasks. And to render those tasks, I'm going to use the other component that we synced down, the task component. And I'm going to do that. And with that, we should see our own set of tasks showing up here. Yeah. So so this is how you work with these Plasmic components. You can obviously wire up any props that you want, any other click handlers or whatever it is. And so it's very flexible in that regard. Now, the thing about these UIs is that usually it's not like a one-shot process and you're done. Product teams usually iterate on what they're working on. So so the thing about Plasmic is that it's not just doing a one-time code gen, but this is actually a tool where you can go back into the tool and refine these designs or revisit them or edit them. So to show you that in action, I'm going to get rid of that. I'm going to turn on, I'm going to go to my client and start Plasmic watch mode. And what this does is it live streams any edits I make in the editor into my code base. So I'm going to put this running app on the right, somewhere over here. And I'm going to have my editor, I'm going to resize this window to be on the left. And to show you this in action, let's say I wanted to make some violent changes to the layout of this thing, and I actually want to change this vertical list into a set of tiles. So what I can do is I'm going to double click into this component to start editing it. I'm going to resize it to be boxier looking, and I'm going to actually turn it into a real layout and have everything aligned to the top with some padding all around. And I'm going to take this this checkbox and I'm going to pop it out of its place and drag it down to the bottom right, maybe like so. And I'm going to pin it actually to the bottom right like that. This is actually looking a little too tall, so I'm going to resize it horizontally, make it a little bit larger like that. And okay, so that looks better in terms of what I want my tasks to look like now. But this is still a vertical list. So what I want is actually for this to be a set of rows. So I'm going to switch everything to a row layout. Now everything is spilling off the edge of the screen. So what I want instead is for this to wrap around like that. And I'm going to actually resize my screen just a little bit. And I'm going to set this this whole container to be a fixed width, something like that. Now it's a little bit hard for me to see the difference between these different cards. So I'm going to add some gap in between them on the vertical direction and also the horizontal direction here. So, as I was making these changes, and these are basically some of the more interesting features of the layout engine. Like if you think about how to implement a cross-browser, gap, flex gap, it's actually to do that in a way that is friendly with wrapping and doesn't introduce CSS selector specificity issues. It can be actually quite annoying. But these are all just like very common things that you want to do when you're dealing with layout. And so, this is what Plasmic really tries to streamline a lot. And you can see as I was making these changes, they were live streaming into the actual running app here. So that's the whole workflow of Plasmic. So now you have some idea of what Plasmic is, how it works. I want to peel back the curtain a little bit for the rest of the talk and switch gears into talking about how Plasmic works more under the hood. Because I think it's actually quite fun to dissect. I think some of the technical challenges that I'll talk about, one is really around the state management infrastructure for the app. This is I'm going to talk about maybe just the architecture of the whole app first. The whole studio, this all the Chrome and everything that we're looking at, this is a React TypeScript application. And the canvas that you're working with, actually each of these artboards is also a React TypeScript application. So you're looking at a total of n+1, 4 React applications on screen right now. And basically the studio is directly manipulating the code base for these embedded applications here. And this is a complex client app, right? There's a lot of moving parts here. There's a lot of complex state that you can directly manipulate in a lot of different ways. And that state is then reflected back out at you in also a lot of different ways, just throughout all the different parts of the Chrome here. And so to manage all that state, we actually spent a lot of time worrying about performance specifically. And by performance, I mean latency. Because if you want certain operations, like for instance these dragger operations to be smooth, then you are typically looking at if you want to shoot for 60 frames per second, then you have a frame budget of around 16 milliseconds per frame. Which, if you want to make sure you're not busting that budget all the time, then you need to do the minimum amount of work that you can get away with. And this is where a lot of all the state management frameworks come into play in React. Right? They're all about controlling how much re-rendering you do in response to state updates. But the thing that makes this tricky in the context of Plasmic is that these the latency is one aspect, but it's the combination of latency with scale that is a little more challenging. So by scale, I mean, I'm looking at this project and I see a total of 3 artboards, but if I, have a much more complex project with like hundreds of artboards on the screen at once, then, I don't want to just naively make a synchronous update to my state and then have all the artboards synchronously re-render in response to that. Right? So an example of something we do is we actually break up the re-renderings into discrete chunks that can then be separately, incrementally and lazily evaluated, basically. And so, I could actually show this in action here, where if you watch, I'm gonna, take this artboard as an example. I'm gonna drag this guy around, and as I'm dragging around, watch the other artboards. You might be able to spot there is like this slight delay, actually, that sometimes is more prominent. And that's basically just our scheduler in play. So the scheduler prioritizes the thing that you're directly manipulating as the highest priority, and the artboards around you as next lower priority, and the things that are entirely off screen as lower priority still. So that's kind of how that concurrency works. Another technical challenge is around a feature I didn't actually show in the demo so far, which is code components. So this is the ability to bring in your existing React components that maybe you created yourself or that you have from Material UI or some other component library, and be able to compose new screens out of those as building blocks. But to get these components into the design tool is it's actually quite complex. I mean, everything from just like helping users, developers, package up these components without becoming experts in Webpack, and also just um, dynamically loading these modules into the runtime. You're basically injecting this foreign third-party code into your canvas, and you want to do that in a secure and isolated way. But okay, after you clear those and you actually have this Material UI button rendering and showing up in your canvas, how do you actually work with that? How do you configure it, right? So that's where all the code introspection and the language tooling that we have comes in play. And this is about actually just understanding the interfaces to these components. And so the tool basically crawls your code base, finds all the components in it, surfaces them, and reflects out their interfaces, whether these are documented using TypeScript or prop types or what have you. And this can be a little nuanced, right? Because we want to essentially generate a bunch of controls for these components without you having to do that manually yourself. But there's some controls, some props that you kind of expect to be things that are like knobs on the right-hand panel that you can just like, fidget with. But then there's other props like children props or function as child props, where you basically expect to manipulate them directly in the canvas through drag and drop. So these are, these are some of the nuances in how we handle these different cases. There's also, I think, some interesting product challenges to call out. The first is something I alluded to, which is just streamlining layout. CSS layout is one of these things that is, notorious for being hard to use, even for those of us who have, or at least, I've been, doing front end for a long time, and I feel like I still know nothing about CSS layouts. Things like even just understanding when you want these two text divs to sit side by side and stretch to fill the available space given to them. Like you might just think of setting flex to 1 and letting them stretch, but you might be surprised at the results of that. And there's always like an explanation here, which is like flex grow is something that multiplies the flex basis, which whenever you have things sitting in a row, that's like that defaults to the width, and the width of divs defaults to auto, which in this case means the maximum content size. So effectively what you have is these two text divs that are growing at different speeds depending on the whatever text is in them at the current time, which is like almost never what I want. And so, I mean, that's actually, I think, one of the more straightforward examples where there is an explanation. And then there's other cases where, like, I still don't know when percentage heights are actually respected and when they aren't. Like, there's like the declared value and used value in CSS. And, certain things affect the declared value and certain things don't. And the declared value is what the height percentage actually respects. And anyway, there's just like very deep rabbit holes and also just like a ton of different ways to accomplish the same thing. But they all have like different trade-offs that are very nuanced and subtle and can, affect you in different ways. So I think unifying a lot of these concepts, simplifying them, and just making the very common cases of, you typically want your elements to be like fixed size or either fixed pixel, fixed percentage, stretch, or wrap. And that's like, 99% of what you want in terms of sizing for layout. And then like layout itself, there's like stacks and grids, and that's most of the modern I think Plasmic puts a big emphasis on modern layout tools in CSS over the legacy approaches. So, and the last product challenge I'll call out is I was talking about how you can import essentially designs from other design tools like Figma or Sketch, these vector drawing tools, into Plasmic, and that's complex because you have Figma as an example. These are all tools that come from a graphic design background. So you deal with concepts like layers and layer masks and blend modes. And in CSS you have inner and outer shadows, but then in Figma you have like centered borders. So like resolving that impedance mismatch is just one of these things that you as a developer would have to contend with if you were manually translating some design over into code by hand. And so Figma plugin is really just about trying to automate that as much as possible and do all the grunge work of doing that low-level translation into like web standards. Whoops. But I think the most interesting challenge for Plasmic is really around this code integration, where if you think about what is natural for code and what is natural from visual direct manipulation, we essentially want the best of both worlds, right? And find the most natural and flexible interface for doing so. And there's like practical reasons for wanting flexibility. Like at the end of the day, I just need to hook up this my container. I want to replace this contents with like my own set of tasks, right? My own dynamic data, or maybe I want to like wire up a button to a certain event handler, right? I just need to do that. But there's also like aesthetic reasons as well. So what I mean by aesthetic is like, I want to control the interface to my components. I want to control the API to them. I don't want this tool to, limit how I shape that interface. I'll give you one example of this is going back to the code here. This Plasmic ToDoApp, this task component, this is the interface to it right now, where I pass in this this children prop, and it's just the name of the tasks. And so that'll be rendered as the content. And I can also, do this thing where like, because we defined that variant group called states, I can also pass in like, I want these tasks to be rendered in the, completed state or something like that, right? So you can work with the task by default this way. But let's say this is not the interface that I want. What I actually want is for this task to take some object, like my task entry object, like my own task object here, like that, some data object, right? And it internally then from this task object can derive what kind of content it should render, what state it should render in, etc. And so like, this is what I mean by control over the component API. Like this is like, maybe this is the interface that I want, right? So so flexibility is actually really important in this code integration. And so I already talked about, this scheme. This is the default code gen scheme that Plasmic comes with. And basically this is about giving you this library essentially of these Plasmic components like Plasmic ToDoApp, Plasmic task. And then from your own code, you can just import these like we are doing here and render them and, just wire them up to whatever props you want. So it's almost like, you're getting this component library as if it were installed off NPM and then just use it like that. So it's very simple. It's very clear what is like regenerated by Plasmic and what is owned by you, etc. There's actually a very different code gen scheme as well called the direct edit scheme, which I won't talk about. I won't go into the details of here, but it's actually really interesting. The philosophy of that is actually that you have direct access instead of like hiding all the JSX and stuff behind this Plasmic ToDoApp component. you're given direct access to it, and you can just directly manipulate that code and wire props and stuff. And the tool will actually continually merge your edits with the design edits. So that's the direct edit scheme. I think in terms of the impact on our own workflow, so we use Plasmic to build Plasmic, and I think the first thing to call out is that is this design first mentality, where it really forces you to think about what is the end goal that you're driving toward, what is the product and the experience that you want, and then all the code that you write is filling in the logic in service of that end goal. So it's a nice top-down kind of approach to help you make sure you're building the right thing. And you contrast this with bottom-up approaches, where there's definitely a place for a bottom-up approach in a lot of projects, where especially those with high technical risk, but it can also be just a more bumbling approach in certain projects. So that's one impact on our workflow. Oops, I keep doing this. The second impact I think that's worth calling out is if you do happen to be lucky to work with a technical designer, somebody who is able to wield a tool like Plasmic, then I mean, there's just something very magical about running Plasmic Sync and then seeing a nicer version of your whole landing page, show up in your code base without you having to do any work. It's like I think this is actually a really promising sort of angle that we want to explore a lot more as well. Because currently we've been focused a lot on developers, but I think designers, are definitely another audience that we want to welcome into the tool. And then lastly is just Plasmic has helped us eliminate an entire class of visual regression tests and manual tools for doing manual QA. So these are things like in Storybook, there's like a plugin that can show you your Figma designs next to your code components so that you can visually inspect them, make sure that they're similar. And so these are all obviated by the fact that you're directly modeling exactly what the end result should look like in this WYSIWYG way. So it's like a very declarative language that you're using to create your app. I think this is the most fun part for me, is just seeing what folks are creating in this. So we announced this product publicly for the first time a few weeks ago, and so it's been a lot of fun. Plasmic itself, I mentioned, is something that's built in Plasmic, so I can quickly show what that looks like. But basically, let's see. I have my left pane here. I'm actually just going to search for Plasmic Kit. And I'll open up a few of these. We actually have this Plasmic Kit broken up into a bunch of different projects. And it's, being able to break up your projects like that and import projects into other projects is just a feature we recently released. So we've been going a little crazy with that. Yeah, sorry, my computer is actually just like completely chugging, but hopefully these will show up soon. Let's see, maybe this one will load faster. Okay, cool. So this is one example of, there's the Code Sandbox dialog here, which is exactly what we created in the design here. There's the share dialog, which is this guy. A bunch of like random controls. There's this project list, which is just the main dashboard screen that I was looking at here. So that's this thing. There's a settings page. There's like the left bar, all these different left panels that you can kind of switch between, etc. So yeah, that is I think pretty much it for what I wanted to share. So thank you for listening. It's still really early days for Plasmic, so definitely welcome your feedback and your playtesting. And if you sign up and mention this meetup, we do have a wait list right now, but I'll just admit you again right after this. And so, and you can also follow us for updates. We're going to be publicly sharing our progress as we go.
Awesome, Yang. Thank you so much. It looks like a really interesting product. You mentioned a moment ago that you've been focusing primarily on the developer experience, and you're kind of interested in like more of the designer experience now. What do you think right now? I mean, I think maybe I have the answer, but what do you think right now is the right way? If someone wanted to start using this at their company, for example, who is the right person to own that like integration? Like, is it a designer? Like, hey, we're going to use this now to generate our component library, or what's the right in for a company?
Oh, yeah, really good question. So I think the main workflow that we've seen is actually just developers using this in whether it is turning a design that they have been handed from a designer into code, or just creating something from scratch. Most developers actually don't get to work with a designer and are kind of left to fend for themselves. So yeah, I think the workflow is has been primarily centered around building like these whether it's screens or flows out of smaller components. And there's increasingly now also a segment of users that are using this to create the design system itself. So this is like, your actual buttons and checkboxes and selects and stuff like that. And we actually have been paying more attention to this pocket of users, just because I think there's a lot we can do there for them in terms of this is maybe pre-announcing something, but like basically you can we're giving you this these templates for very common primitive components like checkboxes and selects, and you can just like draw boxes. You can design them to look however you want, as long as you have certain variants hooked up, certain elements named a certain way, and then from there, Plasmic can actually give you a fully functioning like autocomplete or whatever it is that you're building. And if you've ever tried building a an accessible select from scratch, it's definitely like not a trivial endeavor. And actually, a lot of this the heavy lifting here has been done by there's this team at Adobe led by Devin Govett, who's like the guy behind Parcel, and they've been working on this set of libraries for React called React Aria, React Stately, and these have been you can almost think of them as the engines for these components, these common component types. So you can actually just take these and attach whatever divs and elements that you want to them. And so that's actually the work that we've been basically packaging up in this, and we've also been contributing back to the it's a phenomenal library. Like sliders and things like that we've added back to the library. So yeah, it's a great project. I'm really excited for that.
Awesome. Yeah, I really appreciate you contributing back upstream to those libraries. I work for GitLab, so we always try to. We're big in open source, so like thanks for contributing back up.
Awesome.
There. Yeah, and in fact, I see a coworker of mine in the chat. So Zach, take it away.
Yeah, so we got 4 questions actually, so I'll kind of shoot them off one at a time here. So
cool.
From Derek Knox, he asks, "Great work. Curious how much time you spent building this."
Great question. So we've actually been toiling it on it for like 9 months, I think, is since basically end of last year. Yeah. So and I mean, the team is incredible. It's so we're a team of 5. There's 3 on engineering, and yeah, it's they're amazing. I completely forgot to mention that something I was supposed to do is that we are hiring. So yeah, if this is, these are the kind of challenges that are interesting to you, definitely let us know. I guess it's hiring at plasmic.app.
Nice.
Sorry for completely dropping the ball on that.
We'll paste it in the stream chat.
Yeah. So second question is Plasmic inspired by Flash? If so, what did you want to keep as inspiration, and what did you want to do differently?
Yeah, really good question. So Flash is definitely like I think one of the inspirations for Plasmic. There are many, but I think the thing that we wanted to make sure we were doing well was fitting with the way that apps are built today, which is largely the world has converged on a lot of these. I think for a lot of good reasons, these compositional component frameworks like React is the dominant one these days on the web, but not just on the web. Even on the mobile native SDKs, we're seeing transition from on iOS, for instance, to Swift UI, and on Android to like Jetpack Compose. Jetpack Compose is much more nascent, but they're all the same general concept of, okay, how do we actually make it really easy to express these like sophisticated compositions of things where you have the ability to pass in components into other components and continually wrap them and nest them. And so, I think fitting well with that paradigm is the main focus in terms of like the code integration aspect.
Nice. So third question, what concerns do you have about rendering performance? You hit on the scheduler a bit, but do you anticipate or have constraints around artboard count and or element counts within each?
Yeah, good question. So no, there's no constraints. It's just a matter of like, if you have many artboards, then you'll have to wait for things to propagate through the artboards. And so if you let's say you make a change to a color token or something like that, right? And this color token is used throughout your all your different artboards, and you're looking at like 200 artboards. Then you'll just have to maybe wait for a couple seconds for those, and you'll actually see this like propagation across the artboards of that color.
Yeah, it was pretty cool. I like that you mentioned you have 16 milliseconds to within each frame to get that timing right. That's a really cool aspect I like. And then the last question from Derek is Figma goes I guess it goes through the canvas route, as I understand it, for the entire design space to ask. I'm confused at how this question looks like it was cut off. Figma goes through the canvas route, as I understand it, for the entire design space to asset mitigating performance issues. I'm not sure what the rest of the question is, to be honest. It got cut off here. I think I might have hit the limit on Twitch.
I think there was a Twitch cut it off. But basically, he's saying it sounds like Figma uses the actual canvas tag to assist in like mitigating performance issues. So they're actually rendering a graphic as you update things.
Right.
I'm not sure what the question is because it was cut off. But maybe talk about why using React to render actual DOM nodes was the better choice in your case.
Yeah, a really good question. So I think this is actually one of the big philosophical differences between the tools. We're not actually interested in building another vector editing tool. That's not like the exciting problem to us. I think what's exciting is actually building for production, like basically expressing components in all of their complexity, right? And you can shirk a lot of that complexity when you're using these graphics tools because you're just drawing pictures at the end of the day. So I think that's the key difference. And so what that means for us is like being able to express the full fidelity of layout in exactly the way you want. As an example, right? You can express like a tiny fraction of what you can do in layout today in Figma and Sketch, all these tools. But that's there's still a very wide gap between that and like actually something that's appropriate for production. So that's one example, is actually embracing the medium that you're actually shipping for. And there's a lot of other smaller examples, like I kind of mentioned the impedance mismatch between like even just dealing with borders and like the way that CSS handles borders is like different from how borders are expressed in Figma. So that's one aspect. And then I think the other aspect is the dynamism, which I haven't really shown in this demo, and frankly isn't like super explored in the app today. But if you start imagining like designing with real data or the context of real data or like real code components that are running in your canvas, doing things like transitions and doing things like swipe gesture handling and whatnot, like this is where things get very like I think the only other approach is if you're trying to do that in the canvas, then you're essentially going to contend with rewriting the stack of browsers in your canvas, which I don't think is necessarily the right focus for vector editing tools. So.
Yeah.
That's actually been one of my, every time I've had to interact with Figma, which is rarely, but in the past I've always wanted like, hey, let me actually like, I want to actually click this and like make it do the thing. And it just doesn't, they don't have those sorts of interactions built in. So
Yeah.
Right.
All right. Oh, you did get the rest of it in there. I'll just kind of shorten it here. At the end of your demo, existing projects that looked large, is there an existing library you're using to chunk the rendering, or is that custom?
That's entirely custom. Yeah, this is part of that state management infrastructure that I was talking about that just like breaks up the work into these like bite-sized chunks and schedules them. And like, you know, the scheduler algorithm, the prioritization, it's all like very domain specific to, you know, we have artboards on the canvas and things like that. So yeah.
All right, well, I'm not seeing any more questions. They
Can I ask a question?
Oh,
Of
yeah,
course.
Anthony.
Yeah, it's super cool. I think it's a really interesting project. And what you were saying, Thomas, about how this would fit in with Redwood, I get what you mean, because what I think is interesting is how we're seeing this kind of convergence with the Jamstack on one end and like the no code, low code kind of GUI editor things coming together. And so that's what I really enjoyed about what you've got going on here, because you guys have clearly put a lot of work into having a graphical user interface while also letting you drop down into the code. So for just like how you communicate about this and how you think about how it sits next to other projects, is that something you kind of think about in terms of like straddling those two worlds?
Yeah, I mean, I think, you know, we're all about, you know, some people like to look at Plasmic and point at it and say, oh, this is like no code, right? This is a no code tool, but that's not how we see it at all. It's, you know, we're very much about code. It's code is still like very useful for actually expressing the behavior and the logic and the business logic and all that, right? We're not trying to like reinvent programming or, you know, reinvent types or anything like that. So yeah, I mean, I think fitting well. So what that means instead is that Plasmic needs to, it's Plasmic's job to fit well with, you know, your choice of application architecture, right? Like you have your own choice of maybe these comprehensive frameworks like Redwood.js, or maybe you're using your own choice of routing library or state management library, or, you know, any kind of front-end infrastructure. And you know, Plasmic just tries not to touch any of that or impose on those choices. And so you're just like importing these components and bringing them up, you know, however you want. So
awesome.
So yeah, so I'm just trying to think through this. In theory here, you know, you spin up a Redwood thing and you give it a cell of like ToDoApp cell, and that's empty basically, but it hooks up some GraphQL stuff. And inside that ToDoApp cell, you just hook up a Plasmic component that you've already designed, feed it some data from GraphQL, and like you're done, right? Like that's the whole thing.
This is why GraphQL is amazing. It's like GraphQL is the best thing ever.
Yeah, there's actually some very exciting stuff with GraphQL that we would love to get to before too long. Yeah.
So I don't want to. You can feel free to decline to answer, plead the fifth. Are you planning on supporting other tools besides React at some point?
Yeah, actually, random bit of trivia is that this tool, Plasmic itself, started not targeting React. It started targeting Vue of all things. And but you know, very quickly we actually decided to just focus on React because, you know, everyone's using React. But yeah, I think definitely targeting other web frameworks is very within reach for us. You know, we have actually one thing we want to do is starting next year actually plant the flags for our open source roadmap, which include starting by opening up our core representation. And it's that going back to that key challenge that I was talking about, that code integration piece. I think that's the hardest problem for Plasmic. And so we want to open that up and just kind of, you know, throw a grenade in there and see basically what I think today we have these tools that can generate code for React and in these two different flavors. But I think it'll be interesting to see, you know, if folks can apply us to environments that we might not have ever even thought of. You know, we're already seeing that actually with Plasmic, you know, getting used in, I think the coolest place where Plasmic is deployed right now is there's this company making these hardware devices for autonomous driving vehicles, these LiDAR sensors, and the control panels on them, they're building using React. And so that's like the most out there environment that we've seen so far. Yeah.
That's cool.